Hey everyone, welcome back to Tech is Strong with Shobit. Today we will covering episode 14 of our FANG system domain interview series. If you haven't watched other episode, please watch and get ready for the interview. Let's come to the topic. Imagine multiple apps running on your system at the same time. For example, Chrome, VS Code, and Spotify. Ever wondered how they all use memory without crashing into each other? That's where virtual memory comes in. Today, we will break it down in the simplest way possible. The problem is your system has limited RAM, but multiple processes need memory simultaneously. If all programs directly accessed physical RAM, they could override each other's data. That would lead to crashes, corruption, and security issues. The solution is virtual memory. Virtual memory creates an illusion each process thinks it has its own dedicated memory space, even though in reality they are all sharing the same physical RAM. This isolation is what keeps your system stable and secure. The key idea is programs do not use physical addresses directly, they use virtual addresses. The system translates these virtual addresses into a physical one. This translation is the heart of virtual memory. Memory is divided into fixed size chunks called pages. Physical memory is divided into frames. Each virtual page is mapped into the physical frame. This mapping allows flexible and efficient memory uses. Let's see page table. Each process has a page table. It keeps track of where each virtual page is located in physical memory. Whenever a program access memory, the system look into the page table to find the correct mapping. Let's see how the address translation happen. A virtual address has two parts. First is page number, second is offset within the page. The system uses the page number to look up the frame in the page table. Then it combines it with the offset to get the exact physical address. Let's see safety and isolation. Virtual memory ensures that processes cannot access each other's memory. This prevents bugs and security issues. Even if one program crashes, other remains unaffected. Now the question is, what if RAM is full? When RAM is full, system moves some pages to disk. This is called swapping. When needed, those pages are brought back into the RAM. This allows system to run more programs than physical memory allows. Let's see the real life analogy. Think of virtual memory like a library. Here book equals to data, shelf number equals to physical address, catalog is equals to page table. You do not search shelves directly. You check the catalog first. That is exactly how virtual memory works. Let's see the recap. Virtual memory gives each process its own space. Paging divides memory into chunks. Page table maps virtual addresses to physical one. Together, they ensure efficient and safe memory uses. Here is a question for you. Why do you think we do not allow programs to access physical RAM directly? Drop your answer in the comment. There is another question, like suppose if the page size is 4 KB, how many bits are needed for the offset? Comment your answer and I will reply. I hope you understand the virtual memory in depth now and you are ready for an interview as well. If you found this helpful, smash that like button, drop a comment if you have any questions, and subscribe to the channel. Stay strong in tech and life. See you in the next episode.